We all want our homes to be comfortable, right? A cozy hideout in the winter, a cool escape in the summer, but doing that without breaking the bank on energy bills, well, that's a whole different story. Today, we're going to get into the science of how we can actually control the temperature inside our homes and stop wasting so much energy.
Think about it for a second. It's kind of a crazy thought, isn't it? Every single month, a good chunk of your energy bill is just gone. It's vanishing into thin air. You're literally paying to heat up your neighborhood in the winter or cool down the street in the summer. So why on earth does that happen?
Well, it's because your home is in a constant, invisible war with the outside world. See, heat naturally wants to move from warmer places to cooler ones. So in the winter, all that cozy warmth inside your house is desperately trying to escape. And the very structure of your home, the roof, the walls, the floors, that's the battleground where this fight for energy happens every single day.
Okay, so to win this battle, we need a game plan. Here's what we're going to cover. First, how we can control our comfort. Then we'll dive into the science behind it all. We'll look at the big payoffs, take a tour of the different kinds of insulators, and finally, we'll check out the scoreboard to see which materials are the real champions.
So let's get right into it and start with our main weapon in this fight, figuring out how we take back control of our own comfort.
And the hero of this story? It's called thermal insulation. Its one and only job is to slow down that escaping heat. Now, heat moves in three ways: conduction, which is through direct touch, convection, which is heat moving through air or liquid, and radiation, which is heat moving in waves. A really good insulator has to be able to fight all three.
But how do we actually know if a material is any good at its job? How can we tell a superstar from a bench warmer? Well, that's where the science comes in. It gives us a clear way to measure performance.
And that measurement is called thermal conductivity. It basically gives a score to how easily heat can pass through something. And here's the most important thing to remember: the golden rule. The lower the number, the better the insulator. A low score means it's terrible at conducting heat, which is exactly what we're looking for.
Okay, so we've got the what and the how, but what about the why? Why should you care about any of this? Let's talk about the big payoffs.
Just think of the benefits like a set of dominoes. It all kicks off with that first win. You reduce heat transfer. And because you're keeping the heat where you want it, you naturally use less energy for heating and cooling. That in turn leads to a much more stable, comfortable temperature inside. And because you're using less energy, you're also cutting your greenhouse gas emissions. It's a win for your wallet, a win for your comfort, and a win for the planet. Everybody wins.
All right, now that we know just how important this stuff is, let's go on a little tour and meet the materials themselves.
So the first way we can sort them is by their basic chemical structure. And that breaks them down into three main families: organic, inorganic, and metallic. First up, the organic category. This includes materials that come from natural sources. We're talking about things like cotton, natural wool, cork, or even cellulose, which is usually made from recycled newspaper. The magic behind these is that their fibers are amazing at trapping tiny pockets of air.
And here are two perfect examples. On the left, you've got that cellulose insulation. It looks kind of like fluffy gray paper. And on the right, natural wool. It works just like your favorite sweater, trapping air to keep you warm.
Okay, next up are the inorganic insulators. These guys are mineral-based, not carbon-based. This group includes some really common materials you've probably heard of, like glass wool, rock wool, and perlite.
A super popular example is this stuff. Rigid foam board. You've probably seen these lightweight boards at a hardware store. They're strong and they're fantastic at stopping heat from moving through walls and roofs.
Now this third category is a bit of a curveball. Metallic insulators work in a completely different way. They don't trap air. Instead, they reflect heat radiation. Just like one of those shiny emergency blankets.
And a perfect real-world example is a radiant barrier. The shiny aluminum foil is often used in attics. It acts like a mirror, reflecting the sun's intense heat away from the house before it even gets a chance to sneak inside.
So that's how we classify them by what they're made of. But we can also classify them by their physical shape.
Yeah, the same basic material can come in all sorts of forms, depending on what you need it for. You can get it in big rolls or pre-cut sheets. Sometimes it's a fluid, like a spray foam, or it can even be loose little grains that you can blow into tight corners.
And you can really see that versatility right here. On the left, we've got insulation in a big roll, perfect for laying out across an attic floor. And on the right, you've got a fluid, spray foam, that's amazing for sealing up all those little gaps and cracks around windows.
All right, we've taken the tour, we've met all the players. Now it's time for the performance review. Let's pull up the scoreboard and see how these materials really stack up against each other. So, just to give you a sense of scale, let's look at the two extremes. On the left, we have our undisputed champion, a vacuum-insulated panel with a tiny score of 0.007. That is incredibly good. Then, on the right, you have something like rubber with a score of 0.35. That's 50 times higher. It just goes to show you how massive the performance difference can be between materials.
Now let's look at the full scoreboard. You can see materials like glass wool and cork are right up there at the top with really low scores. And that's because, remember, they are brilliant at trapping tiny pockets of still air, which is an awful conductor of heat. But as you go down the list to denser materials like plywood, the score gets higher. It's not that plywood is bad, but it just doesn't insulate nearly as well. Every material has a score, and that score tells you the story of how well it can fight that battle for your comfort.
So there you have it. Controlling the comfort in your home isn't some kind of magic, it's just science. It's about choosing the right materials, the ones with the lowest score, to win that constant battle against heat transfer. Which really just leaves one final question. Now that you know the score, what's protecting your home from the elements?